All right, going over your chapter 12 quiz. Looking at question number 1, it says you randomly draw a marble out of a bag containing 8 green marbles, 4 blue marbles, 12 yellow marbles, and 10 red marbles. Find the probability of drawing a marble that is not yellow. So first thing I have to do is determine how many marbles there are in the bag. So I'm going to go ahead and add them first. So I have 8 plus 4 plus 12 plus 10. That's going to give me a total of 34. So I need to figure out the probability of the marble that is not yellow. So I'm going to have my total marbles over the amount that is not yellow. So I have to add all the ones that are not yellow. So I had 8 green, 4 blue, and 10 red. That's going to give me 22 marbles that are not yellow. Simplifying it, and I know it didn't specify what you're rounding to, whether it's a percent, decimal, or fraction. You could have left it as your fraction, but I'm just going to go ahead. We should know how to change it to a percent by dividing. You're going to get 0.647. Changing it to a percent, I'm going to have 64.7%. And just rounding it to the whole, I'm going to get 65%. So kind of answering everything that they might ask me as a question. So please make sure you understand how to do that. You didn't have to do all of this, but we have to still understand how to solve them. All right, the A with the line over it, please make sure you know this because you will see something like this on your quiz. It says, find the complement of probability A. That's what that line is. So all you have to do is I'm taking 1 as a whole and subtracting 0.32. If you subtracted correctly, you should have had 0.68 as your answer for this one. Looking at the next one, I'm still subtracting it by 1, but because I have a fraction, I want to make that 1 whole into a fraction. And again, because my denominator is 9, my 1 whole is the same as writing 9 over 9. And then I'm subtracting 8 over 9, which is going to give me 1 over 9 as a fraction. Keep in mind if this was a decimal, it would have a repeating digit, and we cannot have a repeating digit. So keep it as a fraction. If it's repeating, change it to a fraction. Looking at the next question, same thing. I'm subtracting it from 1 as a whole because it's a decimal. If it was a percent, you're just subtracting it from 100%. So if you subtracted correctly, 0.99 would be my answer. Looking at the next question, it says you roll a 6-sided die 30 times. A 5 is rolled 8. They're asking me for 2 things. The first thing they're asking me is for what is the theoretical probability of rolling a 5? And the next one they're asking for is what is the experimental probability of rolling a 5? Keep in mind, theoretical probability means all of them are equal. They're all equally occurring the same amount of time. So in order for me to find my theoretical probability, how many dice or how many sides do I have on my die? I have a total of 6. And out of those 6, 1 side is going to be 5. So this would be my answer for my theoretical probability. Now for my experimental probability, it's asking for if I rolled it 5 times. Keep in mind, experimental is how many trials did you complete? They told me I rolled it a total of 30 times, and out of those 30, a 5 was rolled 8 times. So I'm going to go ahead and put my 8 on top because that's how many times I rolled my 5. And again, if it can be simplified, you must simplify it. So this simplifies to 4 over 15, and that would be my answer for my experimental probability. Again, you have to simplify it. If it's not simplified correctly, it's going to be wrong. Looking at the next one, it says events A and B are independent. Find the missing probability. So I have to know the formula for independent events. The formula is the probability of A and B equals the probability of A times the probability of B. When it's independent, nothing is getting taken out. So I'm just taking the two probabilities and multiplying them. So solving it, the probability of A and B, they gave it to us, which is right here. I'm just going to go ahead and plug it in. 0.05 equals the probability of A. Again, they gave me that one. Writing it in, I'm going to get 0.25 times the probability of I don't know, so I'm representing that as an x. So in order for me to solve for x, I have to go ahead and divide both sides by 0.25. These are going to cancel out, and if you divide it correctly, x, or the probability of b, is going to equal 0.2 as my answer. Looking at number 7, solving for the same thing. However, they're asking now for a dependent. That means something occurred. Okay, something occurred in order for me to get my b. So the formula for this is the probability of A and B equal the probability of A is staying the same because nothing happened yet, times the probability of B after A has occurred. So something happened, so there's going to be some sort of change. But keep in mind, they're giving me all the information I need. I don't know what my total is, what my total probability is, but I do know what the probability of A is, which is 0.6. And I do know what the probability of B after A is, which is 0.2. All you had to do was multiply those two together, and 0.12 would have been your answer. Looking at the last question on this review, I have a graph. And it says a survey asked 13-year-old and 15-year-old students about their eating habits. 400 students are surveyed. 100 male students and 100 female students for each age group. Okay, that's key. You have to know what that means. The bar shows the number of students who said they eat fruits every day. Keep in mind, this is just the students who eat fruits every day. So looking at A. A is asking, find the probability that a female student chosen at random from the student survey eats fruits every day. So I'm specifically talking about my female students. So I have a total of how much female students? 200 female students, because it's 200 in each age group. And now I need to determine, okay, out of those 200, regardless of the age, how many eat fruit every day? So I have to then add. What am I adding? Looking at my chart, I have 61 plus 58, and that's going to give me 119 students. So looking at it, I'm going to have 119 over 200. Changing that to a decimal would be 0.595. You could also change that to a percent. That's fine. We should all know how to do that, but this is what it would be as a decimal. Looking at my next question, it says find the probability that a 15-year-old student chosen at random from the student survey eats fruit every day. So now I'm specifically looking at my 15-year-olds. Keep in mind I have 100 males and 100 females. So I'm still going to have a total of 200. But now I need to determine, okay, how many 15-year-olds? I'm going to have 53 for my males, plus my females, which is 58. Adding those, you're going to get 111, and then same thing as we did for the previous question, just divide it. It will specify on your quiz what to round to. Any questions on the first page of the review? Okay. Looking at the next page, 12.1a, it says in exercise 1 and 2, find the number of possible outcomes in this sample space, then list the possible outcomes. Please make sure you know how to list them. So looking at this, it says you flip 3 coins. So I need to figure out what is the total possible number of outcomes in my sample space. So if I flip it once, I have a total of 2 possible outcomes. I flip it for a third time, I have another 2, and well, the second time I have another 2, and the third time I have another 2. So I have a total of 8 possible outcomes. Keep in mind it's not 2 times 3, it's 2 times 2 times 2, which is the same thing as saying 2 cubed. Now I need to determine what my outcomes are. I need to list them. So my first flip, I have H and T. My second flip, I'm going to have H and T, H and T. And then my third flip, HT, HT. And then HT and heads, heads and tails. Okay, so creating my branches. This one's going to go here as well as here and here. H is going to go to my T. This is going to go to both. This is going to go to both. And this is going to go to both. So now I'm just following that and listing them. So pay attention to my lists. I'm going to have H, 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 heads, heads. Heads is one possibility. I'm going to have heads, heads. Oh my goodness. Heads, heads. Tails is another possibility. Heads, tails, heads. Heads, tails, tails. Okay, so I kind of did my first ones. Now let me go ahead and look at my second ones. I'm going to have tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. These are all my lists of possibilities that I could have. Okay. And 8 was the number. Looking at the next question, it says, a clown has 3 purple balloons labeled ABC, 3 yellow balloons labeled ABC, and 3 turquoise balloons labeled ABC. The clown chooses a balloon at random. They want me to find the number of possible outcomes in the sample space. So how many total balloons did he have? They told me 3, 3, and 3. So for this one, all you have to do is add them. 3 plus 3 plus 3. That's going to give me a total of 9 balloons. Listing the 9 balloons that I had. And he kind of told us. I have a purple balloons labeled A. Purple balloon labeled B. Purple balloon labeled C. I have yellow balloons labeled A. Yellow balloon labeled B. And a yellow balloon labeled C. And then I have a turquoise balloon labeled A. Turquoise balloon labeled B. And turquoise balloon labeled C. Okay, that's my list of possible outcomes. Looking at the next question, it says, your friend has 8 sweaters. They're telling me the total amount of sweaters my friend has. 3 sweaters are green, 1 sweater is white, and 4 are blue. You forget your sweater, so your friend is going to bring you one. Bring one for you as well as for himself. What is the probability that your friend will bring 2 blue sweaters? Would this be considered independent or dependent? Dependent, because your friend is giving you the sweater, he's not putting it back. So I know I'm going to go ahead and use that kind of information. I'm just going to write it's dependent. And I have to determine my events. Event A is going to be, okay, the first sweater is blue. And event B is, again, my second sweater pulled is going to be blue. So looking at this, okay, what's the probability of him pulling a blue sweater first? They're telling me how many sweaters he had in total. So probability of A, how many blue sweaters did he have? 4 out of 8 in total. You could simplify that or you could simplify it last. Let me go ahead and find the probability of B. Keep in mind, he took the sweater out. He did not put it back. So now there are a total of 7 sweaters, not 8 anymore. And again, he took a blue one out. So instead of having 4 blue sweaters, I now have 3 blue sweaters. All you have to do next is multiply. 4 over 8 times 3 over 7. Just multiplying across, I'm going to get 12 over 56. And I can simplify that, and I'm going to get 3 over 14 as my answer. All right, looking at the next question, I have my diagram here. It says the estimated percentage student GPA distributions is shown. Find the probability of each event. So looking at the first one, it says a student chosen at random has a GPA at least a 3.0. At least means 3.0 or higher. So looking at it, I'm going to have 25%, so I have to add it, plus 12 plus 7. That's going to give me a total of 44. Keep in mind, it's 44 out of 100%, which is going to give me 0.44 as a decimal. And yes, you could change it to a percent and simplify the fraction if you had to. The next one says a student chosen at random has a GPA between 1 and 0, or 1.0 and 2.9 inclusive. So I'm just choosing, it's the numbers in between 1.0 and 2.9. So looking at it, I'm going to go ahead and add 9% and 41. Keep in mind, this GPA right here means it's less than 1. So students got less than 1. 6% students got less than 1. So that should be not added in there. That shouldn't be added in there. That's 50. So I know I'm going to have 50 over 100. Super easy. You could have 0.5 or 50%. Okay. And then looking at the last question on here, it says a bag contains the same number of each of the 4 different colors of marbles, so equal amount of numbers. A marble is drawn, its color is recorded, and then the marble is placed back into the bag. It's placed back, I'm not taking it out. This process is replaced until 40 marbles have been drawn. The table shows the results for which marble is the experimental probability of drawing the marble the same as theoretical. So I'm going to go ahead and do my experimental probability first. So looking at my experimental probability, that means I'm taking the amount of times that I completed that trial. It said it was repeated 40 times. So I'm going to go ahead and put all of these over 40 and simplify what I can. So the first one could be simplified to 3 over 10. And the second one could be simplified to 1 over 4 because I'm going to cross out my zeros, and the rest cannot. Looking at the next one, this one's asking for theoretical probability. Keep in mind, theoretical means it's equally possible. And they said there is an equal amount. So out of the yellows, I have 1 yellow out of 4, 1 red out of 4, 1 blue out of 4, and 1 black out of 4. And looking at it, they said find which marble is the same for both probabilities. And your answer would be your red marble because they're both a 4th. Questions on 12.1. All right, let's go ahead and go to 12.2. Looking at 12.2, the first question says, tell whether the events are independent and dependent. Explain your reasoning. I'm just going to go ahead and underline how I can tell. So it says a box contains an assortment of tool items on clearance. You randomly choose the sale item, look at it, then place it back in the box. Key thing here is they're telling me you put it back in the box. You're not taking it out, you're not throwing it away, you're not eating it. It's being placed back. Then you randomly choose another sale item. So would this be considered independent or dependent? Independent. Looking at the next one, it says a cooler contains an assortment of juice boxes. You randomly choose a juice box and drink it. Then you randomly choose another. If I'm drinking it, am I putting it back? No, I'm getting rid of it. Okay, I cannot put it back, so this is going to be dependent. Looking at 3 and 4, it says determine whether the event is independent. This one says you are playing a game that requires rolling a die twice. Use a sample space to determine whether rolling a 2 and then a 6 are independent events. Would this be independent or dependent? This one's good. This one's independent. Okay, how do I know it's independent? Because nothing's being taken out, nothing's changing. My explanation would be the first roll does not affect the second. Okay, it does not affect the second roll. I'm rolling it once, I'm rolling it for a second time. Doesn't matter how many times or numbers, doesn't matter what I get. It's not going to be affected. Looking at the next one, it says a game show host picks contestants for the next game from an audience of 150. The host randomly chooses a 30-year-old and then right after randomly chooses a 19-year-old. Use the sample space to determine whether the randomly choosing a 30-year-old first and randomly selecting a 19-year-old second are independent events. Are those independent events? No. So this one's considered dependent. How do I know it's dependent? Because once I choose that 30-year-old, that 30-year-old is not going to be replaced. I'm looking at my crowd and saying, you're my 30-year-old, so I'm going to choose you, come stand next to me, and I'm taking it out of my group. Then I'm going to choose something else. So the 30-year-old is not replaced. So it's going to affect my second choice. All right, looking at number 5, it says a hat contains 10 pieces of paper numbered 1 to 10. Find the probability of each pair of events occurring as described. So looking at the first one, it says you randomly choose the number 1. You replace the number. Then you randomly choose the number 10. So is this independent or dependent? This one's going to be independent because I'm putting it back. Okay, so let's go ahead and solve it. My event A, or probability A, is that I chose the number 1. And there's 1 out of 1 through 10, and there's 10 in total. Event B, I'm choosing the number 10. There's 1 10, and there's 10 in total. So all I have to do now is just multiply them because I want the probability after everything has occurred. So I'm taking 1/10 times 1/10, multiplying across. That's going to give me 1 out of 100. Okay, 1 over 100 is my probability. Keep in mind, again, you could change it to a decimal or a percent. Looking at the next one, it says you randomly chose the number 5. You do not replace the number. And then you randomly choose the number 6. So this is going to be dependent. And it's dependent, that means I have to find out B after A has occurred. So my probability of A, my first event, choose the number 5, there's 1 5 out of 10. And then my probability of B after A has occurred. Keep in mind I took that number 5 out. Now I have a total of 9 numbers, and I still have a 6 in there because I didn't touch my 6. I took out my 5, not my 6. So same thing as I did before, just multiply both of them. And I'm going to get, again, 1 over, and this is going to be 90. You can change that to a percent. You could also change that to a decimal. Looking at the last question, it says the probability that a stock increases in value on Monday is 60%. When the stock increases in value on Monday, the probability that the stock increases in value on Tuesday is 80%. What is the probability that the stock increases in value on both Monday and Tuesday of a given week? So I set it up as 60 over 100 times 80 over 100. You could simplify them, or you could just multiply across. 4,800 over 10,000. I canceled out my zeros and end up with 48 over 100. Then I change it to a percentage. You could change it to a decimal. I'm going to get 48%. That is my probability that the stock will increase on both Monday and Tuesday. Any questions on 12.2? Okay, that's it for the review.